Hi, this is Erin Powers. I'm a staff archaeologist with the Applied Anthropology Laboratories at Ball State University. This is the first video of a series of videos that's going to be released during our crowdfunding campaign. For our first topic, we're going to be discussing ground penetrating radar, or GPR, and how it works. So, a geophysical survey is an archaeological method that uses ground-based physical sensing techniques to produce a detailed image or a map of an area. These methods are non-invasive or destructive, which is an important goal when surveying culturally sensitive sites such as cemeteries, which is what we're doing here. So ground penetrating radar, also abbreviated to GPR, sends radar pulses into the ground to image the subsurface. The GPR sends a high-frequency radio wave into the ground, which hits soils and objects in the ground, and these waves bounce back into the GPR, and the time it takes for the wave to come back to the GPR are transformed into an image of what's happening underground. So there's specific equipment for a GPR. First, you have your GPR antenna. You can either attach the antenna to a three-wheeled cart, which kind of looks like a lawnmower, or you can attach it to a flywheel, which is just one basic, like a small bike wheel essentially, and you're able to either push or pull the antenna across the surface and across your grid. So, now that you have your GPR antenna, you have your cart or you have a wheel attached to your GPR, you also have a tablet that attaches to it. So the tablet gets hooked up to the GPR antenna, and pretty much what happens is as your GPR antenna is collecting information, it's storing it in your tablet. So the tablet allows you to actually see the raw data being collected while you're walking and pushing your GPR antenna. And this is really nice, so it gives you a really good idea of the types of features that you're probably going to see once you get back to the lab and start processing your data. So, what we do is we download the data that we've taken onto a computer, and then we upload it into a software called Radan, and that's a pretty standard software. So once you start to assemble all of your files into one complete grid, you'll be able to see the grid as if you were, peeling back the layers into the earth and really start exposing some of those features, which is a super cool process. So one really interesting cemetery project that I came across was the B.F. Randolph Cemetery is located in Columbia, South Carolina, and was established in 1872 and was used for some time after that. And so archaeologists went out and did a GPR survey of areas that were just grassy flat fields to see if there was any unmarked graves in those areas. And what they found was that yes, there were many unmarked graves. What they found was almost 164 potential graves in the cemetery. One thing that was really interesting about this project is not only were they able to locate 164 unmarked graves, but they even determined that some of the graves were stacked on top of one another. So there would be more than one individual within a grave shaft. And that's something that's really interesting, that without excavation you really wouldn't be able to know that. So GPR provides a lot of information to archaeologists without doing any subsurface excavation and disturbing any soil. Thank you for watching this video. I hope it was useful to you, and I hope that this answers a lot of questions that you have about GPR. Please, if you have any questions that I didn't address here, email me or contact me through our crowdfunding website. I will be more than happy to answer any questions you have about GPR, and I will be happy to answer as many questions as I can about the project more broadly. Till next time, take care. What? Do you have a message for everyone?